Good afternoon, guys. I hope you enjoyed your lunch. I am Akash Agarwal. I am working in Swiggy as architect, and I have Swapnil with me, who is our Kafka champion. So today we are going to, give you a little brief about like what is Swiggy, what we do in Swiggy, how Kafka is enabling our, all the near real-time related use cases, how we are scaling our real-time intelligence using the Kafka infrastructure. Cool. So the very first slide is what is Swiggy and why we are using Kafka and how do we use Kafka. So back in 2014, right, like our co-founder started Swiggy with just 6 delivery partners in one part of the Bangalore. And now if you see across pan-India, Swiggy is live, right? Like we just deliver the food and groceries. So Swiggy, what exactly Swiggy does here? So what Swiggy does here is there are main 3 actors here. One is the customer who kind of give orders to Swiggy, the delivery partners who kind of take that order and deliver it to the customer. And for food, it's restaurant partner, and for Instamart, it's our internal, IM pod. So now what Swiggy does it's kind of connecting all these 3 main actors, and we are kind of a hub. We are not just delivering the food or groceries, but we also give a unique experience, and that's the reason why a customer comes to us. So experience in the sense like we give them a reliable transparency, and all these things require sub-second latencies requirement, and all these things we are able to achieve using Kafka infrastructure. Now, why we use Kafka, I already explained. So there are 2 major reasons why we use Kafka in Swiggy. The one thing is we use microservice architecture. And so in a lemon words, let's imagine a user is trying to, make some order in Swiggy. Then what happens? Like a user will come, try to choose his own items, and then finally, create a cart, make the payment, and order done, right? Now, under the hood, if you look, right, it's not that easy, right? Like basically, we are connecting the real world with the software. So basically, what we do here is, once the order is placed, then we need to give that event to the restaurant partner or the pod so that they can prepare that order, or we need to assign a delivery partner so that that order can be delivered to the user. And at the same time, if you see your Swiggy app, right, typically what we do is you can also see the live experience, right? Like where is your order? Like is it with the restaurant partner? Is it assigned to the delivery partner? Where is that delivery partner, right? So all those things we kind of enable using the Kafka infrastructure. The second use case, like all the same microservice or the, when a user try to do something on Swiggy, we collect a lot of events or basically, a lot of signals which is required for our data science or the analytical related use cases. And Kafka is being used as an streaming engine there. Cool. The second thing which we will cover here is, our journey from open source Kafka cluster to Confluent Cloud. So I myself joined Swiggy in 2019. That time we were using open source Kafka cluster. From there, we kind of migrated this to Confluent Cloud. So Kafka is a great tool, and we were able to achieve what was really required. But when you run Kafka at scales, it's not that easy to run. It requires a proper team to manage. So things like cluster management, then basically, when you run Kafka at scales, then there are a lot of configurations which we need to tweak so that your Kafka infrastructure can be optimized, like for the nodes or whatever, like you use, like brokers and everything. So that requires some special, tweaking. A simple example would be, I'm hoping you guys would be knowing, right? Like there is a leader broker, and then you have a replica, like replica leader. Now, under the hood, what Kafka does is there is a replication thread. Now, if you run at a scale, right, where millions of events are coming per second, then you need to increase the parallelism. So all those details you need to kind of look into it, and also, you need to kind of manage that as per your requirement. So all those things we were managing by ourselves, followed by security-related stuffs, patching, upgradation, all those things we used to do by ourselves. Last but not the least is the scaling. So basically, what is the meaning of scaling is, in Indians, right, like IPL is one of the very famous season, right? Or the New Year, when we get insanely high traffic. Now, Kafka architecturally doesn't support auto scale or down scale out of the box, right? Hence, we need to do by ourselves. And we were literally doing it before moving to Confluent Cloud. And it's not that easy. So basically, in Kafka, what happens? I mean, there are multiple brokers, right? So scaling out means what? I mean, when you want to scale up, you need to add multiple brokers. But does it work? Not really, right? Because still your partitions are on the old brokers. So you need to really move your partitions as well to the new brokers, and all those things are, were kind of semi-automated, but it required us to kind of keep track of it. Again, I don't have much time, otherwise I could have gone into very detailed, but hence we decided to, decide to use Confluent Cloud. So now if you look at, in Confluent Cloud, what we get here is the scaling. So like the same thing what I was just discussing right now, right? I mean, when we need to scale up our Kafka infrastructure, we don't really need to do it manually because Confluent gives you out of the box. Basically, it's, web UI or API is there where we can just say that how much scaling is required, or when the events is done, can we scale it down. In fact, we are planning to do this auto scaling and down scaling, like based on our traffic as a regular practice. Now coming to the operational overhead, it has also reduced because Confluent takes care of most of the infrastructure related part. Monitoring, so one of the things which is very crucial in production is like how is your Kafka brokers, how many partitions are there, topics are there, how the inflow, outflow is happening. All this monitoring Confluent give you out of the box. Then upgrade, security related stuff, right? It will be taken care by Confluent, so you don't really need to invest our bandwidth there. While we could also do that, but our thought process was, should we really do that, or should we concentrate much on the business side of the things and kind of don't reinvent the wheel again. And since Confluent is already solving it, so let's just use that as it is. Next slide, please. Cool. So what we have done is for Kafka there are two main thing, right? Like one is producer who writes data to Kafka, and the second thing is the consumer who kind of read data back from the Kafka. What we have done is we also built a unified Kafka library. And why we have built that? Because it kind of helps us, right, to make our things standardized. We can have good governance because that library is in place, and we can also get insights out of it. So I'll just give you a little brief, right? So while Confluent kind of take care of the infrastructure part of it, but again, when you use Kafka at scale, right, where let's say if one service is writing millions of events to Kafka and reading it back, right, then it's not that straightforward. Basically, there are a lot of configurations which you get in producer and consumer. What we have done with our experience, all those configurations we tried to edit in the library, and we have abstracted all those things out from the developer, so they can concentrate only on the business side of things. If really required, they can overwrite, but most of the cases, it's not really required. Like maybe there are some corner cases where they would, kind of overwrite those things. Then in Kafka, right, like typical any other queues like SQS and all, right, there you get in consumer fault-tolerant support out of the box. It's not there in the Kafka infrastructure. So in this library, we build it. So what we do here is in Kafka consumer, let's say if there is any, any transient error which is which can be recovered, then what our consumer need to do, they will just, give a message like soft failure. And what this library will do is, this library will write those messages to the read-write topic, and it will again give it back to the consumers on the specific period of time, like backup time and all those things are managed in the library. So each and every use case or every developer doesn't need to reinvent it. Second thing is DLQ. Basically, dead lateral queue is again the same use case. If there are non-retrievable error, basically permanent failure, right? Then they need to, like the consumer will just give message like hard failure. What library will do? This library will write those messages to the DLQ. So what we have done in the DLQ is like there will be little higher TTL there, so that the message will not lost from there. And also we have good amount of monitoring and alerting out of the box available there, so that the on-call can go look at the message, failures, and then automatically kind of fix it. Last but not the least is the metric. So since we have a central library, right, for both producers and consumer, so how it helps is all the metrics that are related to like what is the response time from the Kafka, or how much throughput we are writing or reading, the number of messages which we are reading, writing, all those things are standardized with these metrics. So now what happens if if a developer wants to write some new producer or consumer, he doesn't really need to worry about it. Automatically, since this library is in place, which will emit all those metrics to our internal infrastructure, and automatically we have built the dashboards and alerting, which will take care of it. Next slide, please. Cool. So the next topic is Kafka consumer canary, like what is the complexity around it and how we have solved it. So I'm hoping you guys would be knowing what is canary, but I'll still give you a very little brief. Canary is like, let's say if you want to release your feature to production, but you don't want to impact all your traffic, right? Like in Swiggy terms, I would say we don't want to release it to entire audience or for all the orders, right? Then canary help us to ensure that we do a, kind of controlled release to the production. So basically, while, we have great like unit testing, functional testing, what we do, or the PSRs and all those things, what we do in the lower environment. But there will be sometimes some corner cases which we cannot test out in the lower environment. And that is where canary actually play the role. What canary will do, any new feature which we are releasing, I will control it using the canary, like, just deploy this for 1% of the users. So in case if there are issues, my 99% users or the orders are not really impacted, right? So that is the use case of canary. Now, what is the complexity I'm talking about here is, typically in HTTP or gRPC world, right? Like, while it's not very trivial, but it's not that difficult, right? Because there what we have is load balancer. In load balancer, since we have a good control on our traffic, so we can, pretty much decide like how much traffic we want to send it to the production deployment versus, production nodes versus the new canary where the new feature is released. But that is little complex in Kafka consumer. Why? Because in Kafka consumer, what happens is we don't have a direct control on top of, like like how many threads will be there, how much traffic will get on one specific consumer nodes. And hence, there is a complexity involved here. So I'll just give you a simple example. Let's imagine there is one topic in which there are 3 partitions. Okay. And what we do is, like, let's imagine there are 3 different nodes, and each node, one thread is there who is reading from this partition. Now, let's say in one node, I'm deploying the canary, like the new feature release, whatever I've done. What happens here is, so typically, again, it's not guaranteed, but we can imagine that around 33% traffic will come to that node. Now, I don't really have a control on the traffic. So as soon as I start the canary, 33% traffic will get impacted. That is the problem statement. Now we evaluated multiple options. Unfortunately, in lightning talk, I will not be able to cover that. But what we have done, I will cover that. Can you go to the next direct? Yeah. Yeah. So if you look at, there are 2 different, diagram you will see. So what we do is, there is one left-hand side diagram and there is a right-hand side diagram is there. So in left-hand side, if you see, producer is writing to main topic. And again, the library which I was explaining, right? The same library help here as well. So what that central library help here is, like, a producer writes to main topic, and then we also have a canary topic there. In BAU, once the canary is not running, all my consumer groups read from main as well as canary. Once the canary is started, then what happens is, the consumer A, which was reading from the main topic and canary, now it will only read from the main topic, and it will write that X percentage of message, like 1%, 5%, whatever we decide, to the canary topic, which will be consumed by my canary consumer. And that is how we are achieving the canary in Kafka, consumer side. Yeah, so this is the last topic for today. This is last but not the least. So basically, we have data intelligence platform, which is centralized platform in Swiggy. And I'll let you know, what exactly we do in that platform and how Kafka is helping here. So as I mentioned initially, right, in the initial slides, we have microservice architecture, and then when a user try to, make an order on Swiggy app, we get a lot of events and signal, right, which is required for all our, analytical and data science, and, like all the AI related use case what we are now building. So how Kafka help here is, Kafka is the backbone where, all these events will first go to the Kafka. Kafka will be used as a queuing here, and then, these messages will either be used for real-time streaming to enable some real-time analytical or data science related use case, or that message will go to our lake in which we can do all the batch related use cases. So I'll give you a few examples, right, so that you can relate, like because I'm hoping most of you might be using Swiggy. If not, please start using it. So basically, when you try to make an order to Swiggy, right? So what you do, I mean, once you open the app and try to make an order, you will see that, like maybe that order will take, let's say, 20 minutes or 5 minutes or 10 minutes, right? In quick commerce, like 10 minutes or 15 minutes itself is big. We try to optimize as much as possible. Now it's not that easy because right? Like there are a lot of factors involved here, like what time you are ordering, from where you are ordering, what is the load on that restaurant partner or in the dark store where we have groceries, what is the delay, traffic on the road. So what we do here is Kafka is used to get all those signals, and then we give the predicted SLA so that user will know that once I'm making an order, I will take maybe, let's say, 10 minutes or 15 minutes to get that order. Second thing is driver assignment optimization. So basically, when you make an order, then what happens is under some background service will be there, right, which will try to assign a delivery partner for that order. So we figure out what will be the efficient delivery partner for that specific order, and that is where, again, Kafka help. Then we have a recommendation engine, like for food and Instamart both. So that is what I was talking about, right? Like we are not just delivering the groceries or the foods, but we also give a unique experience, right? And that experience is very personalized to a specific user. And that, again, it's enabled using the Kafka as a backbone. Now, while all these things I specified from the consumer angle, right? But we are actually hyper-local business, right? And our delivery time, if you see, it's like less than 10 minutes or like 10 minutes to 15 minutes in groceries and like 30 minutes plus for food, or again, like less than 30 minutes in some cases. So what happens is we have to take a lot of business decisions in real time. And so basically decisions like, maybe let's say how many delivery partners to deploy, what to do we need to increase the delivery fees and all those things. So like, again, there are multiple use cases. So all those things are kind of, we were able to enable using the Kafka. Now, this data infrastructure, kind of help us to build all these systems. We have wrapper around all those things, and like our internal stakeholders, right? They just use our wrappers and then kind of enable this use case. And now how Kafka help here is, so basically Kafka help us to kind of, scale as and when we need, like, we can build our highly scalable system. We can build fault-tolerant system and a very low latency systems. That is where the Kafka is being used. Cool, guys. Thanks. We are hiring. Please reach out to us in case if you are interested. Thank you, guys.
So if you have any questions, please let me know.
Yep. Guys, we have very short period of time, but again, I'll try to answer as much as possible here. Still, if you have doubts, I'm here. We can connect personally, and yeah, you're getting the mic.
I have a small question. So you mentioned during canary you consume...
Sorry, where are you?
Yeah, here. To your right.
Okay.
Here.
Yep.
Yes, all right, so you mentioned for the canary, your consumer canary consumes and reproduces back to the topic. Could you just brief on that, how exactly that works?
I would let Swapnil answer that.
Yeah, sure.
Yeah, please, Swapnil.
So basically in BAU, what happens is the main consumer or the consumer which is already running is reading from both the topics, the canary topic and the main topic. Now, as soon as the canary is deployed, let's say the service canary is deployed, automatically there is a dynamic config which gets changed. If you see the next picture, in that what happens is the main consumer stops reading from that canary topic, and the canary which has come up will always only read from the canary topic. Now, because of this switch, the main consumer will start producing some percentage of messages, some X percentage of messages to the canary topic, and that will be consumed by the canary consumer.
Basically, what you want to know, I'll just cover that part of it. How consumer is at runtime changing, is it? Cool. So actually, not just this, like forget about the canary. In fact, like initially I covered that part as well, right? Like where the retry exceptions, like transient failure versus permanent failure, right? So there also, your actual consumer is not doing it. We have a library. So consumer is kind of using that library. In that library, we have that support. So for each topic, when a topic gets onboarded, we have an automation. So for each topic, when it's get onboarded, we also create a retry topic dead lateral queue, and canary topic out of the box. Now what happens, once we enable the canary, that time, that library, like all developers doesn't need to worry about the canary. They will just say, I need 5% canary for my consumer. Now what that library will do, as soon as that 5% canary is started with our automation, this will keep listening that event from that automation. And then your library, which is being used by consumer A, that library will read from the main topic because it's already reading. And once the canary is started, it will start writing that X percentage of message to canary. So you're right. Basically, now your consumer, the library part, it's not just the consumer, but it's also producer.
Hi, my name is
hi.
Varun. I'm from the Timken company.
Sure.
Big user of Swiggy as well.
Yeah, thanks.
So you mentioned about the fault retry queue. You mentioned dead letter queue, canary queue, and I mean it can go further from there. You can have your trigger queue, your reply queue for asynchronous responses, etc. Here's a question: is that a feature request to Confluent for you to be able to have such options at the time of topic creation? Because I see the fact, I completely understand you creating a library for your personal requirements, but I see the fact that you have to create a library as missing standardized functionality.
Yeah, great question. So basically, yes, you are right. So, we are actually influencing Confluent charter as well. And definitely this is one of the requirements which we have discussed with the Confluent. But till they release, this library will be there. Once this gets added in the Confluent itself, because we don't know, right, like when they will actually release it in the production for the, cluster what we are using. Again, it's not there, it's not even there in their roadmap. So once it comes, definitely I feel like it's a very, very standard thing which any customer would need and it will really help. But it's about Confluent when they deliver it. So in fact, since you asked me, right, we are also influencing their charter for like disaster recovery. Then they have, right now they acquired like Flink developers are there with them, right? So they're also giving managed offering for Flink and connectors also they are giving for MySQL, I mean the RDS and the, DynamoDB. So our plan is to leverage that as well. So we only influence those charters for Confluent. Yep. Thank you.
Hey, this is Daya.
No issues, you can directly talk.
Yeah. So, hi, I'm Ronak. I'm from Amagi. So, I was just wondering, is the processing of this real-time processing, right? Is it happening via consumers or are you also using Apache Flink for more getting close to the data source, which was mentioned in the today's keynote?
Very good question. I think I could have added one more slide. So we do use Flink. You use the right word. It's just that what we have done, we are using the Flink. I mean, we're just discussing the same, right? And what we have done, we have built a wrapper on top of Flink as well. So our customer doesn't really need, I mean, customer in the sense, internal stakeholders, they don't really need to go into the detail what Flink does, what it doesn't do. And they just have to write like, the core logic and Flink will take care of everything. In fact, the predicted SLA, what I was referring, it is being, it is being like enabled using the Flink architecture only.
Thank you. Thank you very much, Akash. We would honor the next speaker. So
Sure.
again, a big round of applause to the Swiggy team, Akash and Swapnil. So Akash, you could just take questions once you're out of
Sure.
the stage.
Thanks a lot, Deep. Yeah,
Thank you
I'll
very
maybe answer it later. Cool, guys. Thank you.